Today we're learning to use point-slope form of a line. Now it differs from slope-intercept form in that instead of using the y-intercept, it uses any point on the line. The problem with this form is that every line has an infinite number of points on it. And so when you're using point-slope form of a line, you could have an infinite number of equations, an infinite number of possibilities for writing the equation for one line, as opposed to slope-intercept form where you have only one possible equation. But this is what point-slope form looks like. And m is still your slope, and x1, y1 is any point on the line. And so this is really helpful to use as a stepping stone to get from a slope and a point to y-intercept form, to slope-intercept form of a line. And that's a lot of what we're going to be doing with it today. We're going to start with point-slope form, and then we can rewrite it in slope-intercept form in some cases. Now notice that we have written here minus x1 and minus y1. So when x1 is positive, you're going to see a minus there. When x1 is negative, you're going to see a plus there. And the same goes for y. So we've got to be careful of that and not get confused. Let's look at example 1 in the lesson. You want to write an equation in point-slope form of a line that passes through the point 4, -3, and has a slope of 2. So remember, our point-slope form of a line looks like this. All we have to do is plug in the information that we know. So based on what they've given us, what is y1? -3. It's the y value of the point they gave us. What is m? 2. That's the slope they gave us. And what is x1? 4. The x value of the point they gave us. So all we need to do now is simplify just a little bit. We don't want to take it too far because we want to leave it in this form. We're going to simplify that to y plus 3, because minus and negative becomes positive, equals 2 times x minus 4. That's the simplified point-slope form. So we can use that also to graph an equation if we have it in point-slope form. Instead of starting with a y-intercept, we just start with the point they gave us. So if our equation is y plus 2 equals 2/3 times x minus 3, the first thing I want to do is identify the point that I need to hit. And the point that I need to hit comes from the x1 and the y1. So what's the x1? Positive 3, because no, it's x minus x1, so that means 3 is our x1. And what's y1? -2, because since it's y minus y1, then when we have positive 2, that means that it had to have been a -2 to cancel out and make it positive. So that's where we place our first point, at 3, -2. Then we use our slope to find another point. So what's our slope? 2/3. So that means we have a rise of 2 and a run of 3. And since it's positive, we're going uphill. So we're going up 2 and over 3. So there's our next point. Or we could go downhill if we go backwards, down 2 and over 3. There's another point. So all we have to do to draw a line is connect those dots. And there's our line. Now, if we're given a line, and we're given 2 points, say -1, 3, and 1, 1, and I want to write an equation in point-slope form, I have 2 possibilities, because I have 2 points given. So one of them was -1, 3, the other was 1, 1. So pick one of the points. Let's go with the 1, 1. So that means that y1 is 1. So we've got y minus 1. And x1 is also 1. So you have x minus 1. What's the slope between the 2 points? Well, we know it's going to be negative because it's going downhill. and it's going down 2 and over 2. So a rise of 2, a run of 2 gives us a slope of 1. So we don't even need to write the 1 there. We could just put a negative sign because there's kind of an implied 1 there when we have that negative right next to the parenthesis. And so that's the slope-intercept form. Now I could have, or point-slope form. I could have written it with the other point and used y minus 3, my other y, same slope, and x, but it'd be plus 1 because my x1 is negative 1, so minus negative 1 is plus 1. Let's look at a word problem. You are designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Write an equation that gives the total cost in dollars of stickers as a function of the number of stickers ordered. Then find the cost of 9,000 stickers. So the first thing we want to do is look at this. Our output is cost. So that's going to be our y, cost. And our input is number of stickers. So we'll put an S for the number of stickers. Now, we have 2 points, if we think about it. But instead of using 2 points, let's look at this as a slope and as a y-intercept. Now the first thing we want to do is say that we're going to sell the stickers as in groups of thousands. Okay, that seems to be how they're ordered because we're paying $80 for each additional thousands. So let's just use S as thousands of stickers. So that makes this point, instead of being 225 and 1,000, that means when we buy 1,000 stickers, we pay $225. And our slope is $80 over every 1,000 stickers, which is 80. So this makes it a little simpler. We don't have to deal with fractions, and we're only purchasing stickers in groups of thousands. So now all we have to do is plug them into our point-slope form. So we said our slope was 80 because our cost is going up 80 for each additional 1,000 we buy. And then we got to put in our point. Well, our x1, our number of stickers in the first case, is 1. So we're going to do s minus 1. And our c1, the c value that goes with that, the cost that goes with 1,000 stickers, is 225. So there's our function in point-slope form. Now, it says to write an equation that gives the total cost as a function of the number of stickers. So when they say that, write an equation that gives cost as a function of number of stickers, they're asking for slope-intercept form. So we're going to convert our point-slope form to slope-intercept form. Now the way we do that is fairly simple. Our first step is to use the distributive property on the right side, which gives us 80s minus 80. Then we add 225 to both sides. And we get C equals 80s plus 145. There's our function. Then they ask us to find the cost of 9,000 stickers. So what are we going to put in for S? Not 9,000, but 9, because remember that stickers, that S is thousands of stickers. So since we're purchasing 9,000, we're going to put in 9 for S. And then we just simplify. Oops. And we see that it will cost $865 for 9,000 stickers. Last example. You have a table giving the cost of visiting a working ranch for one day and night for different numbers of people. Can this situation be modeled by a linear equation? if possible, write an equation that gives the cost as a function of the number of people in the group. So remember that a linear equation has to have a constant rate of change. So what we would have to do in order to determine if it could be a linear function is we need to compare the input and output, the number of people, and the cost, and calculate various rates of change and make sure that it's always the same amount. So let's look at our rates of change for several of the intervals. We could check between 4 and 6. We'd do 350 minus 250, that's our change in output, over 6 minus 4, which is 100 over 2 equal to 50. And let's check from 6 to 10. So 10 minus, 550 minus 350, our change in output, over 10 minus 6, which is 200 over 4, which is 50. And when we keep checking these, we'll find that our rate of change is always 50, which is helpful because not only does it prove we have a linear function, but it gives us our slope. So to write the point slope form, we already have our slope. If cost is our output variable, we got slope is 50, and the number of people is our input variable, then we just pick any point from the table and plug that in for our input and output. So our n1, our input that we're using, is 8, so we get n minus 8. Our output that we're using is 450, so we got c minus 450. Now, in order to write this as a function, we have to convert it to slope-intercept form. So we use our distributive property on the right, and then we add 450 to both sides. And that gives us c equals 50n plus 50. So there's our function. Alright, if you have any questions, feel free to ask. You can go back and watch the video again if you need something clarified, or you can start on your homework.